So today we're going to cover section 5.2, which you can see deals with probability rules. So first, just some important vocabulary in regards to probability. When we're talking about probability, the list of all of our possible outcomes of a chance process is what we refer to as a sample space. So for instance, if I were going to roll a single die, my sample space would be 1, 2, 3, 4, 5, 6. A probability model or probability distribution, those are used interchangeably, includes two things. It includes a listing of the sample space and then a probability for each possible outcome. So here's an example. It says give a probability model for the chance process of rolling two fair six-sided die, one that's red and one that's green. So my sample space is shown by the 36 different possibilities shown in the diagram. So there are 36 possible outcomes, and then you can see since the dice are fair, each outcome is equally likely, so each outcome has a probability of 136. So by including the sample space and the probability of each outcome, I have created a probability model or probability distribution. Now, sometimes when we're working with probability, we don't want the probability of just a single outcome. We're trying to find the probability of a collection of outcomes. And when we talk about a collection of outcomes from a chance process, we refer to that as an event. So for instance, when rolling two die, the event could be that the sum is 5. The event could be that the sum is more than 8. The event could be that the sum is even. There's a lot of different options for what an event can be defined as, but when it combines more than one outcome, we call it an event. And the way that we use notation to refer to the probability of an event and probability is we name our events with capital letters, so we usually call it event A, event B, event C. And to write the probability of event A, we write P parentheses A parentheses. So for instance, in this small example shown on the slide, it says if we define event A as a sum of 5, if you look back at the sample space, you can see there are 4 outcomes that result in the sum of 5. So since each outcome has probability 1/6, the probability of event A would be 4 over 36, or 1/9. You should always simplify if you can. It says suppose event B is defined as the sum is not 5. We'll define the probability of B. It'll be 1 minus the probability the sum is 5. So 1 minus 4 over 36, which will give me 32 over 36, or 8/9. Now in example 4, it says imagine flipping a fair coin 3 times. Describe the probability model for this chance process and use it to find the probability of getting at least one head in 3 flips. So first let's do the probability model. Probability model consists of listing all your possible outcomes and including a probability for each outcome. So you can see up here on the top of the slide I have 8 possible outcomes when it comes to flipping a coin 3 times. And the probability that each outcome occurs, since it's equally likely, is just 1/8. So now if I want to find the probability of getting at least one head, I just count the number of outcomes that have at least one head. There's 7 of those. And divide by the total number of outcomes. So I could write it as probability of A equals 7 over 8. Now, next I want to look at some basic rules for probability. You don't need to copy the rules shown in blue because they're written in a little simpler terms on the next slide. But a really important feature that can come into play when we're dealing with probability is outlined on the slide, and that's the idea of 2 events being considered mutually exclusive. 2 events are called mutually exclusive if there is no possible way that they can occur together at the same time. For instance, when rolling a die, it's not possible to roll an even number and roll a 3. Those 2 events are mutually exclusive because a 3 and an even number have nothing in common. However, rolling an even number and rolling a number greater than 4, those events are not mutually exclusive because they both include the outcome of 6. So the 5 basic probability rules you want to write down. First says, and the probability of any event is between 0 and 1. A probability of 0 means that the event will never occur, and a probability of 1 means the event will always occur. If S is the sample space, the probability of S equals 1, that just means if you add up the probability of all possible outcomes, it should sum to 1. Third rule, if all outcomes are equally likely, then to find the probability of event A, you just take the number of outcomes corresponding to event A divided by total number of outcomes. Next, the complement rule to find the probability of a complement. That's like when we were looking at that past example to find the probability that the sum of the two die was not 5. You just take 1 minus the probability the sum is 5. So just looking at the opposites, complements are just opposite events. And then finally, the addition rule. To find the probability that event A or B occurs if they're mutually exclusive, so meaning they have no probability, no common outcomes. So the probability A or B occurs is found by just adding together the probability of event A plus the probability of event B. So in this example shown on this slide, you're given a probability model, and you're asked to show that this is a legitimate probability model and then find a particular probability. So to show that this is a legitimate probability model, we just need to recognize that each probability is between 0 and 1, and if I sum all the probabilities together, it does equal 1. So those two facts combine to tell me that this is legitimate, this is a possible, real probability model. Then part B, find the probability the chosen student is not in the traditional college age group of 18 to 23. Two ways you could find that. Here it's found by using the complement rule, so 1 minus the probability the student is from 18 to 23, so 1 minus 0.57. Or you could just add up 0.17 plus 0.14 plus 0.12. Now example 5 says randomly select a student who took the 2010 AP Stats exam and record the student's score. Here's the probability model. So part A is just show that this is a legitimate probability model. Well, since all probabilities are between 0 and 1, and when I add all the probabilities together equals 1, this is legitimate. Part B, find the probability the chosen student scored 3 or better. Well, that means they got a 3, 4, or 5. So I just add all those probabilities together to get 0.584. And finally, part C, find the probability the chosen student didn't get a 1. Easiest way to do that is just use the complement rule, 1 minus the probability the student did get a 1, which simplifies to 0.767. I'm going to jump to our next slide. So next in your notes, I want you to write down the general addition rule. And what the general addition rule tells us is, well, if sometimes events are not mutually exclusive, so the addition rule that we copied down in our basic probability rules only applies for mutually exclusive events. When two events are not mutually exclusive, we have to use the general addition rule, which you can see to find that probability. We use the rule probability that A or B occurs equals probability of A plus probability of B minus the probability that A and B occur. The reason we subtract off the probability of A and B occurring at the same time is because if it's possible to occur at the same time, we've added it in twice, once with the probability of A and twice with the probability of B, so we have to subtract it off. Here, just kind of showing you a little bit how we can use Venn diagrams to help us when working with probabilities. You'll see some in some examples that we work with. Again, actually, I'm going to jump back here real quickly. You can see if I have two separate events, the intersection is shown by the overlapping area, and the union would be everything combined. So looking at this Venn diagram that's included here, here it looks like we have a two-way table outlining the gender of a person and then whether or not they have pierced ears. So it says define event A as male and event B has pierced ears. So if we wanted to divide up our numbers, you can see, well, males that have pierced ears would be that intersection area, so that's 19. There are 71 males that don't have pierced ears. Those are shown in the yellow. And there are 84 other people with pierced ears who are not men. So you can see in the intersection of the two circles is male and pierced ears, so 19. Or if you wanted the probability, 19 out of 178 is the probability of being male and having pierced ears. Probability male and no pierced ears is 71 over 1/878. Female and pierced ears is 84 out of 178, and female and no pierced ears is 4 out of 78. Oh, sorry, 178. So finally, in example 6, it says, what is the relationship between educational achievement and home ownership? A random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. Overall, 340 were homeowners, 310 were high school graduates, and 221 were both homeowners and high school graduates. So we can represent this data in a variety of ways. I asked you in this example to just create a two-way table to display the data, and then use the two-way table to help you find probabilities. In the next example, we'll also use a Venn diagram. So first, my two different features or two different variables that were being measured is whether or not the person in the sample was a homeowner or a high school grad. So you can see I arranged the numbers. I knew there were 500 total people. 221 were both homeowners and high school grads. A total of 310 were homeowners, which led me to know that 89 high school grads were not homeowners, and so on. So I filled out the table. That was part A. Now using that, part B says, find the probability if we chose a member at random that the member is a high school graduate. Well, we take the total number of high school grads over the total number of people, so 310 over 500 equals 0.62. If you had a question like this on the AP Stats exam, you definitely, absolutely have to include the fraction form first. In fact, you could leave your answer just as 310 over 500. But if you just gave your answer as probability of high school grad equals 0.62, you would not get full credit on a free response question because the graders have no way of knowing where you got that number. Now part C says, find the probability the chosen member is a high school graduate and owns a home. Well, a high school grad that owns a home, there are 221 of those out of the total 500, so 0.442. Finally, find the probability it's a high school graduate or owns a home. Well, to find that, we'll use the general addition rule, which tells us the probability that someone is a high school grad or owns a home equals probability of a high school grad plus probability they own a home minus the probability that they're a high school grad and own a home. So finding those values from the table, you can see I add and subtract the appropriate values and end up with an answer of 429 over 500, which simplifies to 0.858. And finally, we're going to end with example 7, which I did not realize I didn't have the work included on here. So, you know what? Why don't we go ahead and complete example 7 together in class, and we will end there. Thank you so much.